Today we're doing the third set of notes in the matrix chapter. So at the top of the page it asks about the multiplicative identity matrix. Yes, I'm aware I have a typo on there. It says identify, it should say identity. The identity matrix looks like so notice I have 1, 0, 0, 1. And if we're trying to prove two matrices are the inverse, I have to multiply A and B together and get the identity matrix. And then I have to reverse the order. And if I get this result, then I would say that A and B are the inverse. So they are inverses of each other. So we're going to do just that first example. We're actually going to skip that 3 by 3 and we're just going to do that 2 by 2. So here I have this 2 by 2 matrix and I'm trying to prove that they're the inverse of one another. So I'm going to multiply A times B. And remember, A times B, I'm doing the row by column. So I have 1 times negative 2, which is negative 2, and 2 times 3/2, which is 3. Moving over, doing 1 times 1, and 2 times negative 1/2. Moving down to the second row, I'm doing 3 times negative 2, and 4 times 3/2. So I could do 4 divided by 2, which is 2, times 3 is 6. Again, you can use the calculator for all of this work. The next spot I'm doing 3 times 1, which is 3, and 4 times negative 1/2, which is 2. And notice by doing this, I get 1, 0, 0, 1. Now I need to do the reverse order of B times A. So I'm just going to kind of take that out. So this is 1, 2, this is a negative 1/2. So now I'm doing row by column. And you might be more of a visual person, you might have to actually rewrite B times A first, and that's totally fine. So I'm doing negative 2 times 1 and 1 times 3. Then I'm doing negative 2 times 2, which is negative 4, plus 4 times 1. Moving down to the next row, I'm doing 3/2 times 1, which is 3/2, and negative 1/2 times 3/2. And for that final spot, I'm doing 2 times 3/2, which is 3, and 4 times negative 1/2, which is 2. So notice again I get the identity matrix. So we would say that these two matrices are the inverse of one another. So go ahead and pause the video and try the practice problem letter A, just the 2 by 2, and I'm going to put a multiple choice question up in a moment that we'll see if you got that question right. So the next thing I want you to notice is that it says determinant, so I actually want you to keep flipping in your notes. Go back to the back page where it says the inverse of a 2 by 2. So I think I kind of did this a lot of order. I want to find the inverse first, and then we'll go back to determinants. So if I have this matrix of A, B, C, D, now remember these 4 things represent numerical values. If I find the inverse of matrix A, out front we do a fraction of 1 over A times D minus B times C. So notice I'm multiplying on the diagonal. And then within the matrix I scramble it up. So D and A flip-flop on that diagonal. B and C stay where they are, but they become the opposite sign. And that's how you find the inverse of any given matrix. So let's go ahead and try those 2 example problems. So here I have matrix A. So to find the inverse, again, we put that fraction out front. So it's A times D, which is negative 9, minus negative 6. So this will, double negative turns into a plus, so I get negative 1/3 out front. Now that I have that fraction handled, now I gotta go inside to the matrix and I have to flip-flop things. So the 3 and the negative 3 switch on the diagonal. The 6 stays where it is but becomes negative, and the 1 becomes positive. And then the last thing that you have to do is the whole idea of scalar multiplication, multiply everything by negative 1/3. So for the top I'll get negative 1, positive 2, negative 1/3, and a 1. So this right here is our inverse matrix. So if I were to multiply the original problem by this one, I would get that whole idea of the identity matrix, 1, 0, 0, 1. So let's try one more example together. So again, to find the inverse of b, I have 1 over 4 times 2, which is 8, minus 6. So my fraction out front is a half, and now I need to do some scrambling. So 2 and 4 switch, and 2 stays, it becomes negative, 3 stays, it becomes negative. And then the last thing that we do is multiply everything by a half. So I get 1, negative 1, negative 3 halves, and a 2. So this is our inverse of b. So again, I would like you to pause the video and try the 2 practice problems that are below this, and I will, a multiple choice question will be coming up momentarily to ask what you got. Alright, so now I want you to flip back in your notes to go to the back of that first page, 5 where it says determinant. Today we're only going to be doing the 2 by 2. We'll save that 3 by 3 for tomorrow. So if I have this matrix A, B, C, D, the determinant represents one single number. Okay, so the determinant is one single number, and the way we find that one single number is doing A times D minus B times C. So notice you're going to recognize that that's comes from where we find the inverse. So when you find the inverse, it's 1 over that. So we're just going to do, again, example letter A. So to find the determinant, sometimes you'll see this notation. So notice it's just like straight bars. They drop the brackets. So the determinant would be 15 minus the negative 2, which is 17. And that is our determinant. So there's one more problem below this. Again, letter A, so you're just going to do it 2 by 2. And then a question again will pop up asking you to fill in your answer.